Alright guys, so next thing is this. Uh, so there is a library here, numpy np, and what is numpy is a numeric engine under all of this. Okay, we will need some function of this. It's numpy. I will tell you what it is. So let's we tell you this feature names is equal to vectorizer. Where this vectorizer is coming from? Vectorizer is coming from here. TF and IDF vectorizer, okay, from sklearn, scikit-learn feature extraction of text. Okay, so we get vectorizer 5,000 live this and it's to English. Okay, and okay, vectorizer dot get feature names out. Okay, so what it will do, it will give the all those 5,000 vocabulary words in a column order. Okay, now okay, so what is this? It is the we have trained the model right here. So we have trained the model and 4,000 iterations. Now this will get some weights, right? So what it will do, model of COEF 0. So this will give us the learned what the weights are, updated weights. Okay, like this is a judges scorecard after that, and one weight per word it will have. Okay, so this is array is the model's knowledge. Okay, now let me see. Top positive we are using the argument sort method of numpy. Okay. So it's a it will rank the weights. Okay, we grab the 15 most positive weights and piece in sort order from this array, and then 15 most negative weights. Okay, and let me print those also. Then most negative. Okay. So, like, some words will be the most positive word will be, let me tell you how. So this is like let me do you. Let me find you the weights. What happened? Okay, so I have to do this. Okay. Okay, so you can see the most positive words are life, fantastic, perfect, definitely, loved, amazing, classic, enjoyed, fun, today, like these. Okay, these are the most positive 15 words in the reviews, and these are the most negative words: worst, bad, waste, terrible, awful, boring, poor, worst, script, horrible, dull, instead, just, make. Okay. These are just based on the uh, based on the weights these words got, right. So what happens is we have this feature array. Okay, and this is these are the words. Okay, vectorizer we have and get feature names out, and this will give the array of the words, right. Then this coefficient is हेलो. हाँ भाई. हाँ जग रहा हूँ, बता. क्या? कार्तिक. कार्तिक को मैं जानता हूँ, ये इधर का जो लड़का है कार्तिक नल्ला, क्या नाम है उसका. तो मुझे ध्यान नहीं आ रहा. बता क्या काम है, करवा देते सी. क्या सामान? अरे रख जाना, आजा रूम पे आजा. 186 पे आजा. ठीक है. Hmm. So then it's yes. Then have this array and आ जा भाई। किस कौन काट देगा भाई ये सब?
उस दिन मेरे और पीयूष के साथ एक और बंदा था।
अच्छा अच्छा, हाँ समझ गया। वो जो हाँ मैं समझ गया, उस लड़के को पेंशन दिया।
मैंने इंट्रोड्यूस करवाया था ये हमारे पार्लियामेंट के।
इधर जो हम आ रहे थे जब, क्या कर रहा है वो? बैठ बैठ।
वो तो अभी घर गया है, वो भी एमएस करने वाला है यहाँ पे।
यहीं पे वो कहाँ जा रहा है? घर कब?
सुबह 6 बजे निकलना है यहाँ से 6 बजे।
अगर तेरी इंटर्नशिप खत्म हो गई तो कर जा रहा है। अरे वेल्स फार्गो ने दी है टी शर्ट।
असली के पत्ते हैं?
पता नहीं है किसके।
पहले से थे। असली की एक इसका है, 2 अब मैं
एक उसका एक मेरा।
अच्छा, यहाँ पे लगाया क्यों नहीं? ऐसे ही
हाँ
बैठ गया। अभी भी ये जरूरत पड़ता है?
अब कहाँ जरूरत पड़ रहा है? पानी भरा ही रखा है, चला ही नहीं।
क्या कर रहे थे?
कुछ नहीं कर रहा है, लेकिन उसको थोड़ा सा
इतने मोटे बुक्स, नोटबुक्स। एआई से भरा पड़ा है क्या?
यही का है यार।
एमसीपी एमसीपी सब लिखा है।
अच्छा रफ है।
सब कुछ है, डीसैप्स वीसैप्स।
एक सेमेस्टर है पूरा इसमें। पिछला और क्या अलग से कौन छोड़ना नहीं।
सिंगल सोर्स शॉर्टेस्ट पाथ।
सब इसी में है।
एओएस जूनियर्स, एओएस भी है, जूनियर्स को दे देना ये।
जूनियर्स भी फेल होंगे फिर।
सब्जेक्ट डिसाइड कर लिया कौन सा लेना है?
जो सब लेंगे हम भी उसी को ले लेंगे। क्या डिसाइड करना है? एक डिस्ट्रीब्यूटर तो लेना है, वो फाइनल है। एक आईएच ले लिया।
किसके अंडर?
आरसी प्रसाद है कोई।
ऐसे मिल गया, मेल किया?
मेल किया था वो।
कुछ इंटरव्यू वगैरह कुछ नहीं लिया?
इंटरव्यू किया है, वो एक टॉपिक ही ऐसा बता दिया मैंने उससे, वो उसने कहा मैंने भी नहीं किया इस पे काम। आजा।
कौन सा टॉपिक?
ये जो मार्चिन पे काम करता है।
ओके ओके समझ गया।
तो मैंने चंद्रयान 3 का डेटा
उससे जो बता रहे थे।
हाँ चंद्रयान 3 का डेटा है, उस पर मैंने प्रोजेक्ट दे दिया उसे कि ये कर लेते हैं। ठीक है कर ले। फीस भर का पोर्टल स्टार्ट हो गया क्या फीस वाला?
कब से चालू है?
इसका फीस का?
हाँ
फीस कभी भी भर सकते हैं।
29 है शायद लास्ट।
इसका मुझे बैंक में मेल करना पड़ेगा। तेरा भी सीन है क्या बैंक का? है कर दिया तूने सीन सेट?
घर जाके करूँगा।
मतलब इनसे उसका फीस का एस्टिमेट लेना है।
50 रुपए देने हैं कॉलेज वालों को, तो वो एक भेजेंगे कितना तुम्हें
हाँ
फीस भरना
और
है,
उसको
बस
बैंक को
खत्म।
मेल कर देना,
खत्म।
इतना करना है बस। अरे, कर्जे में फीस चुकाना बहुत आसान है, मेल इधर से इधर सर खिसकाएंगे।
चलो मैं चलता हूँ फिर।
सुबह
जल्दी
निकलना है
सोना
तुझे
है।
जल्दी।
हाँ।
क्या वो करिए, फ्लाइट करिए क्या?
नहीं नहीं, गुड नाइट।
गुड नाइट। All right. So we were having this discussion. Okay, now here, right? So from here, what we will do, we will get the words, right? Array of, we are converting in the array of feature names, okay, and then we have the weights also in this array from the model. Now we are finding those weights, we are finding the top weights, okay, because each weight this array is like from weight is from 1 to like this indexed wise, right, this array. So we are finding top feature names and top negatives, right? Okay, then what we will do, let's do chat with this def predict sentiment, right? There will be some text of str type, right, and this will also return str. Now like now what we will do, we will wrap this pipeline of everything, like we will vectorize one text and after that we will predict the confidence of it, okay. So vector of this text is this, equal to vectorizer, we have dot transform, right, text. What we will have the words in mathematics, right? Then what we will do, we will predict model dot predict vec, right, 0. What is this doing? We are giving the weight vector and that vector is getting multiplied by the model weights with 0, okay. Okay, then probability is this, model dot predict proba vec 0, then max, okay, max, okay. This predict probable returns the probability of negative, probability of positive. Okay, so it will be the sigmoid output theory. Max is the confidence. Now we will have this label is equal to positive, no, not like that, positive. Okay, if a predict equal to 1, else negative. Okay, like this, and then we will return what, and after that we will return a string of label, right, and confidence probe, right, percent. Okay, after this we will print this. Let's print this. Predict sentiment, right, this product exceeded all my expectations. Okay, like this. Absolutely fantastic, like this. And another review will be like this. Predict sentiment is like complete waste of money brew after 2 days. Then current predict sentiment is like it's okay, I guess, right, you can do this, nothing special, right, and it's like another thing, predict sentiment with this is not good at all. Alright, so this last review is just a trap. I planted not good, so it has bag of words is like good, right? So it's a good has plus positive weights, and not is weak weight. Okay, if the model calls it positive, that's the word order blindness, right? So embedding transformers will fix this. So let me show it to you. What? So see, this is not good. It's showing positive. Why? Because this not is not negative. Just a weak weight, right? And good at all like this. Now how everything is working. So what happens? This text goes here, right? Then this vectorizer transform this text into a vector. Okay, vector means what? It will tell like how many times good is there, how many times all is there, how many times age is there, right, in the dictionary and in the vocabulary, and give the vector. Alright, 1 2 times it will count. Then so model we have weights, right? For model we have weights. Then for every word we have some weight, right? Positive or negative, right? So these words will get multiplied with this vector, and it will give some score. Okay, it will give some score in this array. Okay, then predict model or predict takes some matrix like or array like, right, and return the array only, and then type. Okay, so you can see in the parameters here, array like sparse matrix of shape and samples and features. right? It can take as input data matrix of which returns the array of samples of n samples. Okay, vector of content. So that's why we are this 0, right? We are x is the first element, then predicted weight we will have, and probability model dot predict provides like it's a probability estimate. Okay, like you can see here, confidence 73%, confidence 77%, like this. So it's giving us the probability. Return estimate of all classes are ordered by the level of classic. For multiple array like shape vector to be scored, and where n sample is number of samples and features. Alright, so that's it. If label is equal to positive, predict is equal to 1. Okay, else negative, which means what? So if it is positive, because we are taking through a sigmoid function here, right? So if prediction is 1, then it's positive, else it's negative. Okay. So yeah, this is all positives, and take review text from chat, and so you know this is sarcasm. This is not good at all. So sarcasm can defeat this. Okay. Now what we will do? We will save the model what we have built, right? Model means like the weights. We will save it. Okay. So for that we have to import this job library. So it's a standard tool for saving scikit-learn objects to disk. Okay. It's faster than Pickle for NumPy heavy objects. So let's do this job library, and from path lib, like import path. Why we are doing this? 2x path. Okay, path let me see, dot slash models. Okay, and make directory exist. Okay, equal to true. So it will create a models folder at project root. Okay, because the notebook lives in the notebooks, right? So exist okay is true, don't error if the it is already exist. So is there any model folder there? No, so it will be created, and there these models will be saved. Okay, then after that what we will do, job lib dot dump model we have, right? Where we want to save this, here models less sentiment, right? Model dot job lib. Alright, and job lib dump vectorizer, because it has the those vocabulary, right? Vocabulary of riser dot job lib. Okay, so what it is doing, like it will serialize both objects to the files. Okay, because they are objects, right? The model expects vectors built with the exact same vocabulary, right? So that's why we are saving the vectorizer also. Model without its vectorizer is a lock without its key. So a classic production bug is there, like they travel together. Okay, we need vocabulary also, because we have to get some text, and then we have to get some text. We want the exact same thing, right? Like same weight should be given to the same word. That's what I meant. Okay, so vectorizer will give the same index to all of those words, and according to the vocabulary, right? And then those index will be found with the in the model at the same index. Okay, so we can match the weight. Then vectorizer is without its key, a classic production package. It is the travel together always. Okay, so a model is just a rules stored in file, right? Here is literally that file, and tomorrow our package will load it. Okay, and on day 7 an API serves it also, and on day 26 a registry manages its version. So we will do them all. Okay, after this parent saved files. Okay, list where path, right? The air models. Okay, but below this one thing also. Okay, also one more thing, let me see. No, what happened? Okay, so this exists. Okay, is not exists. Exist. Okay, equal to true, right? What happened now? So it's not exist, it's just exit. Okay, exit, exist. Wow, so we have file saved in our here model sentimental analysis dot job lab and here. Okay, now let's go to terminal again, and what we need to do in the .ignore file echo, we have to add this also models slash, because we don't want go dot get ignore. Okay, slash models, we don't want the models also in our GitHub, right? So we will ignore the model folders because they are binary artifacts and they don't belong to Git also. Git is for code, right? But then how do we version that? Okay, in models, so proper answer for this to version models is DVC, and we will learn it on day 27. For now, notebook can regenerate the model anytime. That's why random state matters here, right? Now what I will do, if freeze user require means okay, we will freezing and with the real. Now get add dot, then get comment with message. What is our message? Message is feature first sentiment model with the TF IDF plus logistic regression. Okay, 87. How, what was the accuracy of our? What is the accuracy? 85, I think. Accuracy is 85. 85% race, right? We committed it, and what we will do, we will push u origin where feature first, because we are in this branch, right? Model. So we are just directly merged it, okay, GitHub. Let's go to GitHub now. Where is my GitHub? And I can create some. Where is my review data, right? And committed branches, right? Okay, well, where is my this is my branch, right? Compare and pull request, and I will create the PR, right? So what is this about? It will okay, able to merge, okay, whatever. So let me do this. Created the first sentimental model with a TF IDF vectorizer, okay, and used a sigmoid function for logistic regression, okay. Whatever, just create pull request, and it's checking for ability to merge automatically, okay. Let's let do it their work, okay. You can see how many files are changed, because it was our first file, so there is nothing, see, it's all positive, okay. There is no conflict, I think, here, okay. Go to conversation, merge pull request, because there is nothing, no conflict with branch. Okay, then I can confirm the merge, and tomorrow I will pull it, okay, before it's merged. Now I can delete this branch also, right? So how can I delete? Get delete where what? Which branch was there? Feature slash first ml model. Oh, this is not a. I think get branch D is there, right command, right? Get branch D, okay. So that's I was a bit confused. Get branch D, and which is the feature slash HTML model, okay. And can you read why? Use by work tree. Okay, so I can switch to branch, get to switch main. Okay, then I can delete it, right? Yeah. I think it's merged, bro. What are you saying? Okay, so I have to pull it first, right? So get pull. Okay, I have pulled. Now I can delete it. Okay, branch feature was not found. What? Okay, it's already deleted. Okay. Okay, whatever. I have done. It's done. So fit transform. So we should not never forget the saving the vectorizer model. Okay, vectorizer we have to save the vectorizer also with the model. Okay, and you have to always run cells in order. You cannot do like out of order run, right? And use random state, same random state. Okay, every if there is no random state, then every run will give you different output. Okay, and the accuracy is good, like you should not okay. Now you can like run this with as homework. You can, what you can do is you can try to run this with max features as 1000 and max features at 10,000 and write down the accuracies, right? And try to run n-gram range in the TF-IDF vectorizer. This adds 2 pairs like not good become a feature. So try n-gram range also as a homework. You go and learn what is n-gram and try n-gram range 1,2 in TF-IDF vectorizer. Okay, this will add 2 word pair like not good become a feature like this. Okay, so does the not good trap from 2 days get fixed? Okay, that's one genuinely satisfying. And bonus for you, like research scikit-learn has like multinomial NB naive bias. Okay, swap it in for logistic regression and just a 2 line range, and it's faster and better or worse, like let's see, and drop all your numbers in the comments. Okay, so thank you guys, we'll meet you in the next tomorrow. Thank you so much. Alright, thank you so much.